So if we are given the function, we were asked to write the equation of the function as a piecewise function. So what we need to do is we have to consider either both of these lines. This line that technically continues through here, and this line that technically continues in this direction. So what we need to do is we have to get the equation of each of these lines. Okay? And they're actually related to one another as negative values. So what I'm going to do is I'm going to first find the equation of this line. And the equation of a line, we can start with the equation y equals mx plus b. So y equals mx plus b, we know from previous experiences that b is our y-intercept. So I'm going to substitute in my y-intercept of that right away. Now I need to figure out the slope of this function. Well, what I'm going to do is I'm going to find clear points on my graph that I can clearly identify the rise and run of this graph. So if we take a look, the run of this would be 5. The rise of this would be 4. Therefore, my slope would be 4 over 5. And that would be the equation of this line. Now, when I write this as a piecewise function, I only want to write this line starting from this x-intercept. So the next thing I need to figure out is the x-intercept of this line. Well, what do I know about my x-intercept? I know my y value of this point has to be 0. So I'm now going to substitute 0 in for my y value and solve for x. I'm going to subtract 3 from both sides. I'm going to multiply by 5. And then I'm going to divide by 4. So my x-intercept is negative 3.75. Therefore, when I go to write my piecewise function, this equation of my line, I only want to write this function starting at negative 3.75, and the values of x need to be getting greater than that. So as a piecewise function would be f of x is equal to, I'm going to create my squiggly bracket. My first equation is positive 4/5 x plus 3, comma. Now I'm going to restrict the domain of this function to be x has to be greater than or equal to negative 3.75. Now my other function is going to be the exact same function of this except the negative value of that. So if you were to extend this, you would notice that the y-intercept instead of positive 3 is a negative 3. The slope of this line is also 4 over 5, but it's a negative 4/5. So all I need to do is take this same equation and apply a negative to the entire function. But again, I want to restrict my domain to only graph this portion of that line. So therefore my x values would have to be everything less than negative 3.75. And that is how you write the function as a piecewise function. Now, how would we go ahead and take that and now write it as an absolute value function? Well, technically, if I take the absolute value of this, all of these values are then going to become positive, which gives me this function. So as an absolute value function is simply the 4/5 x plus 3 and the absolute value of that. Because when I take the absolute value of any output value here, will always give me a positive value. So if you think about this original line of y equals 4/5 x plus 3, technically all of these output values, these y values, when I take the absolute value of that, is going to be positive values. So all of these y values are now positive. Therefore, this would be the equation as an absolute value function.